All right, yesterday we talked about, what was it? Had a line segment right here. And so what did we do? You guys paying attention now? What did we do? We found the perpendicular bisector. So what do we have to find here? We had to find the midpoint. And I don't know, about right there. Is that, I'm just eyeballing it. Okay, it's a midpoint. Watch, if I go, we started. Sit. All right. We talked about perpendicular bisector, which means it bisects a segment, right? So that segment and that segment would be equal to each other, and it's perpendicular, which means that would be a right angle right there. Agreed? All right. And then we had a few little easy problems I gave you on the worksheets. That wasn't that big of a deal at all, was it? Pretty easy stuff. So what we're going to do is we're going to translate that into a triangle, right? And we're going to take this triangle. We're going to find the perpendicular bisector. Actually, tell you what. Let's do this first before we do that. Let's just mention one word, right? If I have two lines, they intersect each other, correct? All right? They intersect each other at a point. Now, what if I had three lines? If I had three lines, do three lines necessarily all intersect each other at the same point? No, but if I took this line and I dragged it so that it did intersect at the same point as those other two lines, everybody see that? So all three, that's okay, watch. Now it's perfect. Okay, so now look, all three of those lines intersect at that one point right there. We have a word for that, and we call them concurrent. Write that down. We'll use that from time to time. In fact, this lesson and the next lesson that we do, 5.2, both deal with concurrent lines. And what does it mean to be concurrent lines? They're two or more lines that intersect at a common point. Well, look, actually, let's say, I don't know, what do they say? They say three or more, because any two lines, as long as they're not parallel, will eventually intersect each other, correct? Right? As long as they're not parallel or skew. So if I have three or more and they actually intersect all in the same place, they all intersect in one point, then we call those concurrent lines. Everybody with me? All right, and we're going to refer to that word quite a bit. I just wanted to make sure we knew that word before we do this next thing. All right, let's go back to that triangle that we had up there. There it is. Just like magic, right? So we have a triangle. What we're going to do is we're going to talk about the perpendicular bisector. We're going to do the perpendicular bisector of all three sides of this triangle. All right. So I'll tell you what. We'll just eyeball it and find out where the midpoint is. Is that all right? Let's do this in a different color. Let's go red. That shows up pretty well. So let's do this. Let's look at this side right here. Before we start, let's go ABC. All right. And what I'm going to do is I want to find the midpoint of BC. Stop me when you think it's the midpoint. I would say it's around here somewhere. What do you think? Sometimes I'm to the left a little bit. About right there? Okay. All right. Now that's the midpoint, but we want to find the perpendicular bisector of all three sides. So I'm going to take side BC first and find the perpendicular bisector. So if you said that that's the midpoint, now I draw a line that's what to that perpendicular. Okay, so I'll draw it perpendicular. All right, and so it's perpendicular. Now it's a perpendicular bisector, so this segment right here will equal this segment right here. Agreed? All right, so I've done one perpendicular bisector. Let's do another perpendicular bisector. We're going to do how many altogether if I'm going to do it to all three sides? Three, okay? Pretty easy. So I'm going to do three perpendicular bisectors. Let's take side AB and do the perpendicular bisector. All right, tell me where you think the midpoint is. Right there? Okay. Now, I'm going to go perpendicular to that, don't I? Now, I'm not necessarily going to this point C, am I? No. I'm looking at this angle. Do you see this angle right here? I'm looking at it to see if it's going to be a right angle. Now, I don't really have a way to make sure it's a right angle, but that's pretty close. That looks pretty close to a right angle, doesn't it? Well, it actually does make a difference because watch what's going to happen. What did I talk about right before putting this triangle up here? I talked about three lines being what? What was the word? Concurrent. Concurrent, which means all three lines intersect where? Not in the middle, at one point, at the same point, right. They all intersect at the same point. So guess what? this third one right here, and you may not see this, but this third side, if we drew this thing correctly, so I have to be fairly accurate on this, all right? Now, on this third one, I might have to fudge just a little bit. You know what I mean? Yeah, fudge, all right? Which means just kind of, it may not be exact, but I'm just going to make it work for the sake of making it work. So let's see, where do you think the midpoint is on this side? Keep going up? About right there? Okay. Now I want to go perpendicular to that as well, don't I? So watch what's happening. Well, the cool thing about this, if I draw the perpendicular bisector of all three sides, those three lines that I draw, guess what? Are going to be, now it doesn't look quite accurate, but it's pretty close. Kind of close, all right? So watch. If that's perpendicular right there, guess where they're going to hit? They're all going to hit at the same point. Now, if I was very accurate, if I measured out, I made sure that was exactly the midpoint, and I knew exactly that was 90 degrees, you know, and all the rest, then I'd be very, very accurate on this. I may be just a little bit off on this because that doesn't quite look like 90 degrees, but it's probably pretty close. All right. So we say that all three of those lines are concurrent. In fact, that point is so special it has its own name, and we call this thing the circumcenter. Write that down. Circumcenter. Circumcenter. Okay? Alright, it's called the circumcenter. C-I-R-C-U-M, circum, and then center. C-E-N-T-E-R. Alright? Now, how did we find the circumcenter? We did what? We drew the perpendicular bisectors of each side. Write this down because you're going to want to refer to this later on. Perpendicular bisector of each side. Okay, that's how we find the circumcenter. Write that down. That's pretty important. I'm telling you, it's going to be very helpful that you have this in your notes because at the end of this chapter, we're going to do a whole bunch of other stuff. And this is, since this is at the beginning of the chapter, you tend to forget the beginning stuff, okay, when you get to the end and ready for the test. So it's good to have your notes. You go back on it and look at it, and this is going to be very important to you. Circumcenter is it's the point of concurrency. Do you see that? We call this the point of concurrency where the three lines meet. And how do we get that point right there? We found the perpendicular bisector of each side. All right? So it's the circumcenter. How do we find it? We find it by the perpendicular bisector of each side. We good? All right. Now watch. There's something special about that point. Yeah, they intersect at one point. That's pretty cool. But what's even cooler is this. Watch this. If I, let's go blue. If I started at that point, that point is called the circumcenter. Okay? That point right there is the circumcenter. If I connected that point to this vertex, and if I connected that point to this vertex, to point C, you writing it down? And if I connect this point to the other vertex, which is point A, now if I would have drawn this very accurately, that's why it's kind of important to draw it as accurate as you can. All right, if I drew it accurately, look at these three blue lines right here. What do they kind of look like they might be? Well, they form a bunch of triangles, but just the lines themselves. What do you think? The same lines? They're not the same lines. They're same length. Is that what you said? Okay, I thought you said same lines. You're exactly right. They are the same length. Okay, they're congruent to each other. They're equal. So this point right here, let's call that let's call it P for point. Okay. All right. So from A to P, BP, and CP, guess what's true about all of those lengths? They're actually equal to each other. That's right. So let's write that down. AP equals BP equals CP. All right. And when is that true? That's true when this point is the what? Did we say midpoint? It's the circumcenter. Circumcenter. This point right here, no, center. Right, like the center of a circle, okay? This is the point that's in the center of this triangle. It's the circumcenter. It's equidistant from all three sides. Everybody see that? You paying attention? Okay, I don't think you are. So let's look. This point is the same distance from all three sides. So what do you think they're going to do as far as problems in the book? They'll probably tell you that P is the circumcenter, and they'll say, I don't know, BP is 5. And they'll ask for AP. What would AP be equal to? 5. What would CP be equal to? It'd be 5. Everybody see that? Might not be that easy. They'll probably do stuff like this. Now don't write this down because I don't know if this will come out even or not, but they'll say like this is x minus 7 and this is like 3x plus 1, or I don't know, something like that. You follow me? And then what would you do? You'd solve for x, right? Plug it back in and all that. I don't know if that works, but I'm just saying that that's the kind of stuff that they could give you, isn't it? All right? Because they've been doing that all year long, haven't they? Remember I told you when we first started this that the chapters don't necessarily get harder and harder. It's just different stuff. I mean, don't you agree that you've been doing kind of the same stuff every chapter? Take this side, set it equal to this side. Take this angle, set it equal to this angle. We solve for x, plug it back in. We've done that a ton of times, haven't we? All right, and we're going to keep on doing that kind of stuff, all right? But just with different shapes and different figures and things like that, all right? Okay, so that's circumcenter. Are we okay with this? All right, put that in your notes. We're going to do 4 of these things, all right? This is the first one. So this is number 1. That's the circumcenter. Let's do some more. All right, let's talk about another word. The first word we talked about was perpendicular bisector. We did a whole bunch of stuff with that. Okay, and then we took a triangle and we found the perpendicular bisector of all 3 sides, correct? All right, and then we called it the circumcenter and all that kind of stuff. Now we're going a different approach. This time we're not finding the perpendicular bisector, but we're taking this angle, and watch what we're going to do. We're going to take this angle, and we are going to, what do you think to this angle? We're going to go right in the middle, which would be called a what? A bisector, but not just any bisector. We're bisecting what? Not a segment, but a angle, so we'll call it a what? An angle bisector. So what I'm doing is, see this angle from here all the way to here? I'm trying to split that angle in half, all right? Or into what? 2 equal angles, okay? 2 equal parts or 2 equal angles, okay? So watch what I'm going to do. I'm going to make this thing. Now, would that make 2 equal angles like that? No. Would that make 2 equal angles? No. Tell me when. Up a little bit, maybe right there? Okay, that's pretty close. I would agree with that. So watch. That angle, if that angle and that angle are equal to each other, what do we call this line right here, or this ray? We call it an angle bisector. Okay? Because we're bisecting an angle, right? So we call it an angle bisector. Everybody got it? So what does an angle bisector do? It splits an angle into what? 2 equal angles. Okay? Now I said split it in half. That's what everybody says. And I even kind of made a mistake and said split it in half. But it splits into 2 equal angles. That's what we need to say. All right? Very important. Everybody got that? Yeah. Okay, now what we're going to do is now we're going to take a triangle. And what do you think we're going to do to all 3 angles of the triangle? Find the angle bisector. Okay? That's the whole idea. Remember the other triangle? We talked about perpendicular bisector. And then we took the triangle and we found the perpendicular bisector, right? Now I talked about angle bisector, so what do you think I'm going to do now? I'm going to throw a triangle up there and do what? Find the angle bisectors, right, of all 3 angles. You got it? Yeah. Okay. I'll tell you what, we'll do this on the next video because it'll take a little bit more time than what I have left.